For this video, we're going to look at arcs and angles again within a circle, but this time we're going to throw a little bit of algebra in there. So before we look at some examples, I do want to review that our different arcs and angles that are formed with chord, secants, and tangents can either have an interior intersection, on a circle intersection, or an exterior intersection. Again, just reviewing what we did in the last video, those interior intersections to find our angle measure, we're going to add the arcs together and cut it in half. On the circle intersections, we're just going to take that arc measure and cut it in half. And for our exterior intersections, we're subtracting our arc measures and then cutting it in half. So we're always dividing by 2 or multiplying by 1/2. We're just figuring out if we need to add, subtract, or keep it as is. Looking at our very first example, number 1, we're solving for x. I see that I have that interior intersection, so I know I'm going to be adding those arc measures together. In this case, when I set up my equation, I have the expression is equal to 1/2 and then my arc measure sum. When I solve for x, I'm going to just go through and I find that x equals 14. For number 3, we're solving for x, and this is an example of an on the circle problem. So on the circle, our relationship is we just need to take our arc measure and cut it in half to find that angle. So when I set up my equation, I have 6x minus 38 equals half of that arc measure, 140. When we go through and when we solve for x, we find that x equals 18. Number 5. We're solving for x, and this is an exterior intersection problem. So in order to find that x value for that missing angle, we are going to subtract those arc measures and cut it in half. So 161 minus 65 multiplied by 1/2 equals our expression 7x minus 1. And when we solve, we get that x is 7. A few more examples to look at. For number 7, I have an interior intersection problem that crosses in the middle of my circle. They told me that the arc CB is 5x plus 41. They told me arc AD is 7x minus 19. And then I have that the measure of angle AED is 89 degrees, so that angle right there. We are going to use all of that information of arc AD. So when I set up my equation for this one, we are going to write out that 89, our angle measure, is equal to 1/2 times, and then in parentheses, we're going to add those two algebraic expressions together. Once we solve, we get that x equals 13, and I need to take that 13 and plug it in for the measure of arc AD to answer the question. So I'm going to do 7 times that 13 minus 19 to find that the measure of arc AD is 72 degrees. Number 9, this picture is an on the circle problem. They told me that the arc BED, so our major arc BED, is 15x minus 47. And then we also have that the minor arc BD is 9x minus 1. And we want to find the measure of angle CBD. When we do this, what we're going to do first is we are going to add those expressions together and set it equal to 360 because they make the entire circle. Once we solve, we find that x is 17, and now that I have x is 17, I can use that to find my angle. If I want angle CBD, that means the arc that I'm going to find is BD. So I'm going to take 17 and I'm going to plug it into that expression. The measure of the arc is 152 degrees, and I'm going to cut that in half to find our angle measure. So the final answer for this problem is 76 degrees as the measure of angle CBD. For number 11, we have an exterior intersection. So for that exterior intersection, they gave me the measure of arc NJ and they gave me the measure of arc MK as algebraic expressions, and they also gave me my angle MLK as an expression. And we're going to find the measure of MLK once we solve for x. When we set up this equation, we are going to have the measure expression, so 4x plus 3 for that angle is equal to half, and then subtracting our algebraic expressions. So they have 170 for nj, and then they have the 5x plus 8 for our mk. Notice that I put that expression into parentheses because that subtraction sign needs to go to the 5k and the 8. So just make sure that you are subtracting both so we can distribute that negative. And when we solve for x, we find that x equals 12. X equals 12, we're plugging it back into our expression for our angle measure. So 4 times 12 plus 3 in order to get the measure of angle MLK is 51 degrees. Our last example that we're going to look at is number 13. Again, it's another exterior intersection problem. We have the measure of QTS as an algebraic expression. We have the measure of QS, that arc, as an algebraic expression. And then we have the angle as an algebraic expression. So we're going to write out that equation first, and the goal is to find the measure of QTS. When I write out my expression, I have the angle measure is equal to 1/2, and then the difference between my arcs. Again, we need to write the second arc in parentheses because we're subtracting both things. When we solve for x, we find that x equals 14. And once I have x equals 14, I'm going to go back into the measure of QTS algebraic expression and plug it in. So our final answer is that the measure of our QTS is 247 degrees. And that's looking at our algebraic expressions with our arcs and our angles with algebra. Again, we're using these same relationships with our interior intersections on the circle intersections and exterior intersections for our arcs and our angles.